All right, let's dive into a genuine cosmic detective story. We're talking about a galaxy that the James Webb Space Telescope spotted. A galaxy that, based on everything we thought we knew, just shouldn't exist. It's an anomaly, an impossibility, hiding in plain sight, right at the dawn of time.
And this quote right here from the lead author, Rashi Jain, gets right to the heart of the mystery. You see, Alaknanda isn't just an old galaxy, it's a galaxy that looks ancient way before its time. It's like finding a fully grown oak tree where you were only expecting to see a tiny seedling. It's a complete chronological anomaly. So let's properly meet our cosmic mystery. The galaxy is named Alaknanda, and it was discovered by researchers in India. So what makes it so impossible? Well, we're seeing it as it was when the universe was barely a tenth of its current age, and yet it looks totally formed, stable, and, well, weirdly familiar. Even the name they gave it is a huge clue. They called it Alaknanda, a sister river to the Mandakini, which is the Hindi name for our very own Milky Way. That name wasn't an accident. It's a deliberate hint that this impossibly young galaxy looks a whole lot like our own cosmic home. Yeah, see, Alaknanda isn't just some blurry blob of stars. It's what astronomers call a grand design spiral. And that's basically the textbook definition of a perfect galaxy. Two beautiful, clear, perfectly formed spiral arms. That kind of elegance, that structure, is supposed to be a sign of old age, of a galaxy that's had billions and billions of years to get its act together. Okay, so to really grasp just how much of a rule breaker Alaknanda is, we first have to talk about the old rulebook, the established theory for how galaxies are supposed to grow up. And this chart just lays out the problem perfectly. On the left, that's what we expected to see in the early universe, based on our best models. Total chaos. Clumpy, messy, turbulent galaxies that were still being slammed together. But on the right, you've got Alaknanda. Ordered, symmetric, structurally mature. I mean, the contrast could not be more dramatic. And here's the kicker. This process was supposed to take a very long time. You know, it's a slow, bottom-up job. First, you need gas to kind of drift in. Then that gas has to chill out and settle into a nice, stable, spinning disk. Only then, after all that, can these gentle waves come through and sculpt those beautiful arms. And the whole time, the galaxy has to avoid getting smashed by some other galaxy. The rule book said this whole process should take billions of years, not just a blink of an eye. So you might be wondering, how did we even manage to see this thing? Well, it took a perfect storm of our absolute best technology and a massive stroke of cosmic luck. So this number you see here, Z is equal to 4. That's Alaknanda's redshift. Just think of it like a cosmic timestamp. It tells us how much the light from the galaxy has been stretched out by the expansion of the universe on its long trip to get to us. And a redshift of 4? That puts it way, way back in the early days of the cosmos. To put that redshift in perspective for you, it means we're seeing Alaknanda as it was only 1.5 billion years after the Big Bang. Its light has been traveling for over 12 billion years just to get to our telescopes. We are literally looking at a ghost from the dawn of time. And in that unbelievably short amount of time, it somehow managed to pull together 10 billion times the mass of our sun into stars. I mean, that's a construction speed that our old models would say is basically impossible. Now here's where that cosmic luck comes into play. It just so happens that Alaknanda is sitting right behind a giant galaxy cluster called Abell 2744. The cluster's incredible gravity actually bends space-time, acting like a natural magnifying glass. It bent and amplified Alaknanda's light, making it look twice as bright, and letting us see its structure in unbelievable detail. And this is basically the high-tech toolkit the scientists used to confirm this wasn't some mistake. You've got the James Webb Telescope, of course, to see that ancient light. You've got the gravitational lens giving us a boost. And then they use data from 21 different filters to measure every little detail. Finally, they used powerful software to model its shape and prove, yeah, this is a stable spiral galaxy. This is some seriously rigorous science. So, we know it's real. We know it breaks all the rules. The next big question in our cosmic detective story is how? How in the world did this galaxy get its act together so incredibly fast? Right now, there are two main ideas on the table. The first one is an internal thing called clump dissolution. Basically, giant clumps of star-forming gas inside the galaxy broke apart, and that energy kicked off the spiral pattern. But for that to work, the galaxy's disk of stars had to already be pretty stable and orderly, what astronomers call dynamically cold. The other idea is that something external happened. Maybe a smaller galaxy flew by and its gravity yanked on Alaknanda, triggering the arms. That would probably create a messier, more chaotic structure, what they'd call dynamically hot.
And that leads us to the single most important question scientists have to answer right now to crack this case. Is Alaknanda's disk of stars moving in a smooth, orderly, cold way? Or is it a chaotic, turbulent, hot mess?
And the great news is, we have a way to find out. The next step is to use even more powerful tools, like the ALMA telescope or JWST's own spectrographs, to stare at Alaknanda. They can actually measure how the stars and gas are moving inside that disk. That data will tell them if it's hot or cold, and that in turn will tell us which of those two big theories is probably right. You know, finding one impossible galaxy is cool, but the implications here are way, way bigger. Alaknanda isn't just some cosmic weirdo. It's a piece of evidence that's forcing us to rethink the entire timeline of the universe.
Seriously, this one galaxy matters because it tells us the first chapter of cosmic history needs a rewrite. The early universe wasn't just a chaotic nursery. It was capable of building complex, grown-up structures shockingly fast. It means galaxies are way more efficient at building themselves than we gave them credit for. And here's a wild thought. If galaxies grew up faster, maybe the conditions needed to form planets like ours also showed up way earlier than we ever imagined.
And that's what we're left with. Alaknanda was hiding right there, and we only saw it because of a brand new telescope and a lucky break. So it makes you wonder, what if it isn't a fluke? What if it's just the first of a whole new population of early, mature galaxies? How much of the universe's real story is still out there, just waiting for us to finally see it?